You ask a chatbot a question, and the words start streaming back one after another, after another. Now ask for a whole essay, 500 words instead of 5, and yet it doesn't take 100 times longer. The answer just keeps flowing. That is not an accident, and in the next few minutes, you'll see the simple trick behind it. Here's the puzzle we're going to solve. Every time the model writes one new word, it's supposed to look back at the entire conversation so far. So the longer the chat gets, the more there is to look back at. By all rights, it should crawl to a halt. It doesn't. Let's find out why. This is Glass Box, where we make the hardest ideas in AI feel obvious. Today's question: how does a chatbot stay fast, even in a conversation that's gone on for thousands of words? Quick reminder from last time. A chatbot writes one word at a time. It reads everything so far, predicts the next word, sticks it on the end, then does the whole thing again for the word after that. Writing is just that loop, running over and over. So here's the plan in 5 steps. 1. Why the obvious way is wastefully slow. 2. What each word actually leaves behind when the model reads it. 3. The tricks save that and never redo it. 4. We watch it generate word by word the fast way. And 5. The catch, because this speed isn't free. Part 1. The wasteful way. Picture the conversation as a row of cards on a table, 1 card per word. To write the next word, the model does something called attention. The new word looks back at every card before it, asking each one, how relevant are you to me right now? Now here's the wasteful part. The naive way to do this is, for every single new word, start over from the very first card and process the whole row again. Word 1, reread everything. Word 2, reread everything. 1,000 words in, and it's rereading 1,000 cards, just to add one. Think about how silly that is. You're writing a long letter, and before each new word, you reread the entire letter from the top. The work for one extra word keeps growing as the page fills up. Do that for a long chat, and the model would slow to a painful crawl. There has to be a better way. That looking back has a name we met earlier: attention. It's just every word checking the words before it and deciding which ones matter for what comes next. Real example, like writing the next line of a story and your eyes flicking back over everything you've written so far to stay on track. Part 2. What each word leaves behind. Here's the key insight. When the model reads a word during attention, that word produces 2 little things. We call them its key and its value. And here's the magic. Once a word is written and sitting in the conversation, those 2 things never change again. So every word in the conversation is really a little folder, a key on the tab, a value inside. The new word being written holds up its own question, glances along all the tabs, and pulls content from the folders that match. That underneath is attention. And here's the part that unlocks everything. The word that you wrote 10 seconds ago, its tab and its contents are finished, frozen. They will be exactly the same no matter how long the chat goes on. So why on earth would we recompute them every single time? These are the key and the value from the attention video. Same idea, no need to relearn them. Quick refresher. The key is the little label a word holds up so others can tell what it's about. Picture each word as a file folder, and the key is the tab sticking out. You glance at it to decide whether the folder's worth opening. And the value, you'll remember, is what's actually inside that folder, the real content the word hands over once it's looked at. Tab on the outside, document within. That's the pair attention leaves behind for every word, a key and a value. Part 3. The trick: save it once. Here is the whole idea of the video in one sentence. The first time the model reads a word, it works out that word's key and value, and then it just keeps them, saves them in a little notebook off to the side, and never works them out again. So now adding a new word is cheap. The model works out the key and value for just that one new word, drops them on top of the notebook, and lets the new word glance back over all the saved tabs. Everything older is already done. It's sitting right there, ready to be reused. Notice what changed. Before, every new word meant redoing the whole conversation. Now every new word only computes one word of work its own, it still has to glance back over all the saved notes, and that glance does grow a little as the chat gets longer. But the heavy part, rebuilding everything from scratch, is gone. The cache turned a job that kept exploding into one that barely grows. That notebook has a name, the KV cache, the key value cache. It's simply the model's saved stack of every past word's tab and contents, so it never has to redo that work. Real example, like jotting your notes in the margin the first time you read a page, so on every later pass, you just glance at the margin instead of rereading the page. Part 4, watch it write, word by word. Let's run it for real. The conversation so far is 4 words long, and their keys and values are already in the notebook. The model wants to write word 5. It computes 1 key and 1 value just for word 5 and sets them on top of the stack. Now word 5 looks back. It glances along the 4 saved tabs plus its own, pulls content from whichever folders matter, and out pops the prediction for word 6. Notice, we touched the 4 old folders, but we didn't rebuild a single one of them. Word 6 arrives, and we do the exact same tiny dance. 1 new key, 1 new value onto the stack. A quick glance back over everyone. Out comes word 7. The notebook grows by 1 line each time, and each word only reuses that saved work instead of rebuilding it, so the cost per word stops exploding. And that's the answer to our puzzle. A 500-word reply isn't 100 times harder than a 5-word one because the model never rereads the whole thing. Each word just adds its own page and glances at the rest. The reply keeps flowing fast because almost all the work was already done and saved. Part 5. The catch is speed isn't free. But there's a price, and it's worth understanding. That notebook lives in fast memory, and it never shrinks during the conversation. Every word you've ever said is still sitting in it, key and value taking up space. How many words the model is holding in mind at once has a name, the context length. Real example, like the size of a whiteboard. A bigger board lets you keep more of the conversation in view at once, but a bigger board also costs more and takes up more of the room. So the trade is this. The cache trades memory for speed. The longer the chat, the bigger the notebook, the more memory it eats. That's a big reason very long conversations feel heavier, and why fitting a longer context window is such a real physical cost for the people running these models. So here's the whole picture. Writing is a loop, 1 word at a time. Each word leaves behind a key, its label, and a value, its contents. The naive way redoes all of that for every new word, which is hopelessly wasteful. The fix is the KV cache. Save every past key and value once and never recompute them. New words just add their own and glance back. That's why chatbots stay fast in long chats, and why all that saved memory is the price they pay for it. But here's a question we haven't touched. These models are enormous, billions and billions of parts. When you ask a simple question, does the whole giant thing really wake up to answer, or is there a way to use just the part you need? It turns out the biggest AIs have a clever secret, and that's the very next video. Why giant AIs are secretly many small ones. If this finally made the speed of chatbots click for you, subscribe so you don't miss it. This was Glass Box. See you in the next one.